Hey folks, today we're going to talk about temperature and pressure conversions. Obviously you need your calculator. You should have already done these problems. To be able to do temperature problems, we have to know a couple of conversions. We have to know that to go from Celsius to Kelvin, we have to take our Celsius temperature, we have to add 273 to it to get to our Kelvin temperature. Similarly, if we want to go the other way, we want to go from Kelvin to degrees Celsius. All right, we have to take our Kelvin temperature, we have to subtract 273 from it to get degrees Celsius. Now remember, you can never have a negative Kelvin temperature. All right, so if you're ever confused here and you're trying to think about this, some of the most common temperatures we think about is at 0 degrees Celsius is 273 Kelvin. All right, so if you think of that, how do you get from Celsius to Kelvin? Well, here I added 273. Going the other way, I'd have to subtract 273. All right, so that just kind of should help you as you go through this. All right, so as we go through the chart, we have a Celsius temperature of 15. We're trying to get to Kelvin, so we have to add 273. So when we add 273, we get 288. All right. Now here, when we want to go the other way, we have to subtract 273 from 385, and that's going to give us a Celsius temperature of 112. So I'm going to do that all the way down. I add 273 to the negative 25, and I get 248. I subtract 273 from 273, and this is the very common one. This is 0 degrees Celsius. And 100 degrees Celsius, you're adding 273, so that's 373. Going back to a Celsius temperature, I subtract 273. So from 32, I get negative 241. Remember, you can't have a negative Celsius temperature. You can't have a negative Kelvin temperature. So a negative 300, I add 273, and I get a negative number. Well, that doesn't make sense. Right? I can't get a negative, what is that, 27? No, I can't get a negative 27. Can't get a negative Kelvin temperature. So this is not possible. All right, so it's important you realize that, we could throw in some red herring in there that says, no, that's not possible. All right, 303 going back the other way, we subtract 273 and we get a positive 30 degrees Celsius. All right, so that's it for Kelvin Celsius temperatures. You're going to be doing a lot of those. You should be familiar with those. All right. We have pressure conversions. All right, and so for pressure conversions, you need to know certain conversions. You need to know that 1 atmosphere is equal to 760 millimeters of mercury. It's also equal to 760 torr. Torr and millimeters of mercury are the same. It's equal to 14.70 pounds per square inch, which I abbreviate as PSI. It's equal to 101,325 pascals, which is the same as 101.325 kilopascals. Kilo means 1,000, remember. Right? So those are the ones that we use most commonly. So those are the ones that you should know, and those are the ones you're going to see on the next few pages as we go through this. Right? And everything we're going to be doing is dimensional analysis. Right? So let's look at number 2. We're starting with our pressure conversions. And we start with 1.43 atmospheres. All right, now what we want to do is we want to convert from atmospheres. Since we have atmospheres there, we have to put atmospheres on the bottom. All right, and we want to convert to millimeters of mercury. All right, so let's stop for a second. Do you have all those written down somewhere? Either that or have you memorized them all? All right, because you're going to need them. So I'm not going to keep reverting back to this page because I have memorized all these things. So I'm just going to write them down. So I know that 1 atmosphere is the same as 760 millimeters of mercury. And that's what I wanted, was millimeters of mercury, so I'm done here. So I just multiply these two things out, and I get 1086.8 millimeters of mercury. You just say, well, wait a minute, I've only got 3 sig figs in my problem, so I can only have 3 sig figs in my answer. So that's 1090 millimeters of mercury. Alright, how about the next one? You have 942 millimeters of mercury, and you're trying to get to atmospheres. Well, I do have a conversion factor between millimeters of mercury and atmospheres, and it's that 1 atmosphere is equal to 760 millimeters of mercury. So I take the 942 divided by 760, and I get 1.2394, yada, 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 yada. But I can only have 3 sig figs, so it's 1.24 ATMs. Why is it ATMs? Because my millimeters of mercury cancel out, and I'm left with ATMs. Please cancel your units as you're doing this. Very important. The pressure inside the balloon is 152,346 pascals. And that means I want to get rid of pascals, and in this case I want to go to atmospheres. And I do have a direct conversion between pascals and atmospheres. Now 1 atmosphere is 101,325 pascals. So when I take these numbers and I multiply by 1 and divide by the 101,325, I get 1.50353 da 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 da. So again, how many? Oh, 0.38. I do have to do that. 812, right? And I have 6 sig figs in my problem, so I have to go out to here. So I get 1.50353. It's got to be a 4 because I've got to round up because of the 8, and that is atmospheres. All right, how about my next one? The pressure inside a container is 0.832 atmospheres. And I want to convert to millimeters of mercury. Can I convert from atmospheres to millimeters of mercury? I certainly can. Atmospheres, millimeters of mercury. 1 atmosphere is 760 millimeters of mercury. I do the math, I come up with 632.32, da da da, which I now have to round to 3 sig figs, so it's 632 millimeters of mercury. All right, how about number 6? Number 6, we're talking about PSI this time. That's a new one. 18.9 pounds per square inch. That's how we look at tires. If you look at the side of your tires, that's what you do when you put gas in air in your tires. All right, PSI. That's PSI, and we can go directly to atmospheres. And that's 14.70 PSI in 1 atmosphere. And we do the math, and that gives us 1.2857, yada, 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 3 sig figs, 1.29 atmospheres. All right, number 7. Ooh, this is different. Let's see. Let's look at this for a second. We have KPAs. We want to go to PSIs. We don't have a conversion factor directly to PSIs, but we do have a conversion factor to atmospheres, and then from atmospheres we can get to PSIs. So that's what we're going to do, and in fact all the rest of our problems look like that. We start with 98.324 kilopascals. It looks like we're going to have 5 sig figs in our answer. And we go from KPAs, we go to atmospheres. And then from atmospheres, we go to PSI. And our KPAs in 1 atmosphere is 101.325 KPAs. And 1 atmosphere is 14.70 PSIs. I multiply this whole thing out, and I get 14.2646, da 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 da. So I have to round to 5 sig figs, which is 14.265, and I'm in PSIs. And 14.7 is 1 atmosphere, so that's just slightly under 1 atmosphere. All right, let's keep going. Let's go on to number 8. The pressure inside a container is 871 millimeters of mercury. Now, guys, as you're starting to do this, you can say, well, gee, I'm going from millimeters of mercury to atmospheres and then to pascals. But I just look at that and I can see that that's a little bit more than 1 atmosphere. So if I'm in pascals and there are 101,000 pascals, my answer is going to be 110, 120,000 pascals maybe. So as I look at this, I should be able to estimate my answers before I go and punch everything into a calculator, just to make sure that I get the right answer. Right? That helps me check my work. Right? I'm starting with 871 millimeters of mercury, so I have to get rid of millimeters of mercury and go to atmospheres. And then I have to go from atmospheres to pascals. And in 1 atmosphere, there are 760 millimeters of mercury. And in 1 atmosphere, there are 101,325 pascals. So I multiply this out, and I get 115971, but I can only have 3 sig figs, so my answer is going to be 116000 pascals. Pascals, because that's all I've got left. I canceled my ATMs, canceled my millimeters of mercury. This is simply dimensional analysis. You guys know how to do this. All right. Number 9. Pressure inside a container is 87.4 kPas. 87.4 kPas. Well, that's less than 1 atmosphere, because there are 101 kPas in 1 atmosphere. So I go from kPas to atmospheres, and then I go from atmospheres to PSIs. And 1 atmosphere, there are 101.325 kPas. And in 1 atmosphere, there are 14.7 PSIs. And I multiply across the top, divide by the bottom, and I get 12.6797, 3 sig figs, 12.7 PSIs. Notice my kPas cancel, my atmospheres cancel, I'm left with PSIs. Okay. All right, number 10. I start with 191,800 pascals. Let's see, there are 101,000 pascals in an atmosphere, so this is about 2 atmospheres. And so since torr is 760, it's going to be about 1,400 as a ballpark. All right, so let's see what happens. I go from pascals to atmospheres, because I can't go directly to torr. And then from atmospheres, I go to torr. Now, torr is exactly the same thing as millimeters of mercury. There's 760 in 1 atmosphere. In 1 atmosphere, the pascals are 101,325. If I multiply by the top, divide by the bottom, I get 1438.618, yada, yada, yada. Let's see, 4 sig figs in my problem, so 1439. All right, next one. What's the pressure inside? The pressure inside a container is 172 psi. 172 psi, that's a lot. That's like 10 times normal. So what's the pressure in millimeters of mercury? It's going to be a big number. It's going to be, instead of being 700, it'll be 7,000 to 8,000 maybe, somewhere up in that range. All right, so let's see what happens. 172 psi. I have to get rid of psi's. What do I go to? Of course, I go to atmospheres. And then from atmospheres, what do I go to? Because I didn't want atmospheres, I wanted millimeters of mercury. Well, for every atmosphere, that's 14.70 psi, and 1 atmosphere is 760 millimeters of mercury. My atmospheres cancel, my psi's cancel, I am left with millimeters of mercury. When I do the math here, I come up with 8892.517. Yeah, but I can only have 3 sig figs, so that's going to be 8890. Remember, there has to be a 0 there, right? This is 8,800, so this still has to be 8,800. So this is my answer, and this is in millimeters of mercury. Right, number 12. Pressure inside a container is 593 millimeters of mercury. And I have to go from millimeters of mercury. Well, I want to go to kPas, but I can't get there. I have to go to atmospheres first. And then from atmospheres, I have to go to kPas. Right. Let's see, 1 atmosphere is 760 millimeters of mercury. 1 atmosphere is 101.325 kilopascals. And when I do the math, I come up with 79.06016, yada, yada, yada. But I can only have 3 sig figs, so it's got to be 79.1. And notice I've canceled millimeters of mercury. I've canceled atmospheres. I have kPas left. kPas are what I was trying to get to. So 79.1 kPas. Number 13, the last question. We are starting with kPas, 379 kilopascals. And if I have kilopascals, I can go to atmospheres. Am I done? No, I'm not done because I don't want atmospheres. I want PSI, pounds per square inch. So let's see. This is kPAs. So I have 1 atmosphere and there are 101.325 kPAs in 1 atmosphere. And there are 14.7 PSIs in 1 atmosphere. So my kPAs cancel, my atmospheres cancel. I'm left with PSIs. So my answer is going to be 54.984 da 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 da. I can only have 3 sig figs. So that's, let's see, the 9 is going to round up to a 0, which I have to carry, and I have to guess the 8. So that's going to be 55.0 PSIs. All right, folks, we're done. That's it. If you have questions, please see us in class. We'll be happy to help you. All right, take care. Have a good one. Bye-bye.